Hi, this is the second example we have for the binomial theorem, and now here we want to expand the sixth power of 2x minus 1 over x. Okay, we're going to view this as the sixth power of the sum of the quantity 2x and the quantity minus 1 over x. That is because 2x minus 1 over x can be really just viewed as the sum of 2x plus negative 1 over x. Okay, so we're going to view this term here as the x in our formula, and this quantity negative 1 over x as the y from the formula we mentioned. Okay, and to expand this, we know that every term would just look like, so this is the sum of the following terms, and every term would look like the quantity, the first quantity to the kth power times the second quantity, which is again negative 1 over x, to the 6 minus kth power, because we have here n is equal to 6. Okay, and the coefficient for that would be, again, n choose k, where let me just plug in this n here as 6. Okay, and we are going to plug in k is equal to 0 all the way up to 6. So that is the formula from binomial theorem, and all we need to do next is to plug in the values of k and expand the expression and combine, simplify our result. Okay. This is, so here's the solution. The first term we start from k is equal to 0. Plug it in, we have 6 choose 0, 2x to the power of 0, negative 1 over x to the power of 6, plus 6 choose 1, 2x to the power of first, negative 1 over x, quantity to the power of fifth, plus 6 choose 2, 2x to the power of square, to the power of 2, and negative 1 over x to the power of 4, plus 6 choose 3, 2x to the third, negative 1 over x to the third, plus 6 choose 4. Again, each time make sure that these numbers are matched. Okay, if this is 4, you want to make sure that the power, because we're sticking with using the power of 2x as k, so make sure that this is the same number. Okay, 4 here, then 4 here. For the second quantity, you just have 6 minus that power. Okay, we have the power of the first quantity as 4, therefore here we have 2. Okay, and then when k is increased to 5, we have 6 choose 5, quantity 2x to the fifth times negative 1 over x to the first. And the last term we have would be 6 choose 6, 2x to the power of 6 times negative 1 over x to the 0th. Okay. Please note that although we have, for both terms here, we have x's, we can still use the formula. We can still use the binomial formula just by treating the first, whatever is the first quantity in the sum, as the x, so-called x in the formula, in the binomial formula, and the second one in the sum as y, although there is no other variables actually. Okay, they're both terms of x, but that is fine. We can still apply the binomial theorem in a similar manner. Okay, the only difference that we'll make is once we have both of these terms involving x, some of them actually can be combined and some interesting simplification could happen. Okay, for example, if you consider this term here, I'll just zoom it out here. Okay, if you just consider that term, it's gonna be a coefficient, of course, that's a number, 6 choose 3, but the cube of 2x is actually 8 times x to the cube, and the cube of negative 1 over x is actually negative 1 to the cube, which is negative 1, divided by x to the cube. Now, because these terms are multiplied together, the x cubed term will just get cancelled. So this term eventually will just become a number. It's going to be negative 8 times 6 choose 3. Okay, do you see the idea? Now, please pause the video and try to perform the calculation for all the other terms in the sum, and come back to compare your answer with my solution.